Hi, I'm Chelsea. In this video, I'll be walking you through my process control blocks project. I'll explain how the code works, how each part contributes to the overall functionality, and how the system produces the expected results when creating and destroying processes. This project is meant to simulate how an operating system might manage processes using PCBs. Each PCB stores information about a process, like its relationship to other processes. For example, who the parent is, who the children are, and how the siblings are related. In version 1, I use a class called Process Control Block Entry. Each entry stores the parent process index and a list of child indices using an array list. The toString method formats this info so we can print it out and verify their relationships. The Process Control Blocks class holds an array of these entries. When I call create, it checks to see if the parent exists. It finds the next available slot, creates a new process, and adds its index to the parent's child list. And this structure makes it easy to see all the children of a process. The destroy method recursively deletes all the children of a process. It removes each child from the parent's list, calls destroy on that child, and clears the slot in the array, ensuring that we destroy the process and all descendants as well. Moving on to version 2, it uses a bit of a different structure. Instead of storing a list of children, each process stores just the first child, and then we'll link the siblings using younger sibling and older sibling pointers. So the class process control block entry 2 holds the parent, first child, and sibling pointers. Within the class project control blocks 2, the create method will find an empty slot and create a new process as it did in version 1, but here it will link it to the sibling chain. If the parent had no children, the process becomes the first child, and if there are existing children, then the new process will be added on at the end of the sibling chain. Then moving farther down to the destroy method, it follows the child pointer and walks through the siblings and recursively destroys each one. It produces the same result as version 1 in that all descendants are removed. Moving on to the test file or class, this is where I will verify the versions work as expected. So the test method here will run a loop. Within that, it will create and destroy processes with a fixed pattern. I will use the system.currentTime mills to measure how long each version takes. So here is where it starts, here is where it ends, and that's showing how long it takes to create and destroy within each version. The main function down here tests both versions. It prints out the time each took to calculate and then lets me know which was faster. I'm going to go ahead and run each of these classes to see how they respond. So we'll go version 1 here. Okay, and it has printed out the parent and all the children of the parent process. So here it's showing the parent of process 0 is -1, meaning there is no parent there. Its children are process 1, 2, and 4. Process 3 is a child of process 2. So its parent is listed as number 2. After destroying the children, PCB information, process 0 information, the parent is -1, there is no child. So it has deleted all children of the process. Let's go ahead and run version 2 here. And as expected, it went ahead and printed out all the information on each process. So again, process 0 here is showing the parent is -1 or that there is no parent, it's the root parent. Its first child is process 1 down here. It has no younger or older siblings, as it is the root. Down here, again, it's going to show parent is process 0. Process 1 has no children, but it does have a younger sibling because process 2 is created. So on and so forth. It moves down the list here. Here it's showing the first child of process 2 is 3 because down here, process 3's parent is 2. Its younger sibling is going to be down here at 4. and then the older sibling will be process 1. So again, it's working as expected as well. And lastly, let's run the test file. Oh, I'm so sorry, I did miss one part of the last. Let's see, I don't think that ran properly, so let's try this one. Yes, down here. It's finally caught up to me. Excuse me. Let's see here. Okay, yes, down here, after destroying all the children of process 2, the PCB information is listed as here. So we still have process 0, 1, 2, and 4, and the children of process 2 are no longer on the list, and neither are their descendants. So again, working as expected. Let's come over here. We'll run this test file and see what happens. Going to run. Oh, there we go. Wonderful. My computer is struggling. You had run before. Why? Oh, I think I have to give it a moment. I remember correctly. This is the test class, so it's taking extra time to log the start time and end time. And there we are, wonderful. So version 1 used this many milliseconds, version 2 this many, and version 1 was, as expected, slower. So that is my process control block entry, my process control block project, and I appreciate you listening. Thank you so much.